So I took the three triangles, 30, 45, and 60 degrees, and just sort of replicated on here. So we have all three triangles with the specific calculated points and exact values. So we're going to look for the trig ratios of each of these triangles, all 6 trig ratios. So when we say sine 30, we go to the 30-degree triangle where the principal angle is 30 degrees, and sine 30 means we're going to look for the ratios. So ratios means to compare sides. Opposite hypotenuse, adjacent hypotenuse, or SOHCAHTOA pretty much. So sine 30 is OA. No, wait, it's O. So it's opposite over hypotenuse. In this case, the opposite is this piece, which is the y value, which is 1 over 2. And the hypotenuse is going to be 1. So I'm going to divide it by 1, which is the same thing as 1 over 2. Cos 30 is adjacent over hypotenuse, which is, in this case, it's the x value for here, root 3 over 2 over 1. Which is the same thing as root 3 over 2. Now, tan 30 is OA, opposite over adjacent. Now, the opposite seems to be the height or the y value of this. I'll put here y over x, which is the same thing as what? In this case, we got to do some division. You're going to take 1 over 2 divided by root 3 over 2. And when we do this, you're going to have to take the reciprocal of this, and that gives us 1 over root 3. And I'm not going to rationalize here, so you can rationalize your own. Yeah, let's save some time. Now, cosecant 30 and sine 30, they're reciprocal relationship with each other. So in this case, it would be hypotenuse over opposite. So basically, we're going to take 1 over 2 instead of 1 over 2, which is the reciprocal, which is 2 over 1, which is the same thing as 2. Secant and cosine are related to each other. That means it's going to be h over a. That becomes going to be 2 over root 3. I'm not going to rationalize. You can do that. Cotangent is related to tan, which is in this case is going to be root 3 over 1. So sine 45, all the 45s and 60s, you could pause the video and sort of try this on your own to get the ratios. You don't have to rationalize if you don't want to. So here are the answers. Not everything is rationalized. I didn't do much rationalization. So when you do this question, there seems to be a common theme. Sines, when you look at the sines, you seem to be always comparing the opposite. And in our case, the opposite seems to be always the y values. It's always y. It's always actually y over 1. Y over 1. When I look at the cos seems to be always looking at the adjacent. So this is the adjacent, adjacent, adjacent. It seems like you're always looking at x over 1, x over 1. And tan is a common theme. It seems to be you're always looking at y over x, y over x. So in summary, if you look at the following bottom summary, x and y are points in the unit circle, and it seems like the x's are related to the adjacents, and the y's are related to the opposites. And we just sort of mentioned over here that it seems like the x's, if you notice a common theme, x, we don't care about the 1, doesn't really matter here, divided by 1 doesn't matter. X is cos 60, x is cos 45, x is cos 30. So there's a common pattern here. In other words, x is actually cos angle. And the y, going back to here, let's use blue here, so the y's seems to be, the y is sine 60, the y is sine 45, the y is sine 30. Therefore, there's a common pattern. The y is going to be sine theta, right? Therefore, x is cos theta, sine theta, and this is just written as a coordinate system. That's your x and y, it's cos and sine theta. And this is for a unit circle. So we just established that x in a unit circle is cos theta, and we established that y is sine theta. Now tan, we just mentioned, is equivalent to y over x, so in this case opposite over adjacent. And if you notice, what's really y? Y is actually sine. So in other words, tan theta is, instead of y, we're going to replace it with a sine theta. X over here is the same thing as cos theta. So this here is your first encounter of something that we call a trig identity, which pretty much means you got two expressions. They look different, but they actually are the same. And we will be using this later in future units. there's actually a name for this. This trig identity has a specific name. It's actually called the quotient identity. Because quotient means to divide, taking something divided by something. In this case, you're taking sine divided by cosine. So let's open it up to more angles. So we're going to start from 0 degrees, and we're going to go all the way to 90 degrees. Now, what's the coordinate of this one here? Well, it's a unit circle, so we know that the radius of the circle is 1. So that means the x is 1, but the y is 0, because it's on the x-axis. Over here, this is the y-intercept of the circle, and in this case, it's going to be 0 and 1. And we just established that x is related to cos theta, in this case cos 0. This is going to be cos 30, cos 45, and cos 60. But now we got an extra number, which is cos 90. So let's actually look at the pattern of these numbers. So if we look at the unit circle at 0 degrees, it's here, and the x is 1. But if we keep on going around this circle, so let's actually go from here to here, what happens to the x's? The x's are going to get smaller. So cos 0 degrees is actually 1. That's the x value. Now, if you keep on going counterclockwise, what happens to the x's? They get a little bit smaller. In this case, cos 30 is root 3 over 2. That's where it is. And if you keep on going in this circle now, keep on going, now the x value here is root 2 over 2. So it's getting smaller. These numbers are getting smaller, and you go to 60, it is 1 over 2, and cos 90 becomes a 0. Over here, we talk about y's. Y's are related to, are exactly the same thing as sine theta. In this case, sine 0 degrees. What's sine 0 degrees? Oh, well, the y value here is 0 because there is no up and down. But once we start to move around the circle, I'll use red, it seems like the height is getting bigger. So in this case, sine 30 is going to be 1 over 2. And if you notice, the numbers are actually the same thing as the x's, but going in reverse. So the next is going to be root 2 over 2. I'm not going to write the rest. Over here is going to be root 3 over 2. It's getting bigger because the y's are going upper. In this case, sine 90 is going to be 1. So it seems like there's a pattern with these numbers. So as x gets smaller, as you move from 0 to 90 degrees, the y gets bigger. So in future courses, you will have to know these numbers. So from smallest, 0, in order, 0, then you have a half, root 2 over 2, root 3 over 2, and 1. So in future math courses, you may need to know these values by heart. So what that means is if I say, oh, okay, what is, for example, sine 45? We do expect, some teachers do expect you to know exact values. Now, I know that some students have special calculators where it actually gives you root 2 over 2 directly, but there are some calculators that don't. They'll actually give you 0.70 and all those decimal places. And in some cases, the teachers do not want to have the decimal places. They actually want to have the exact values. So you are responsible to know the exact values of all these special angles. So far we've been focusing on a unit circle where the radius is 1. So we look for the points, this red dot here at 3 degrees, 30, 45, and 60 so far. Now what happens when you don't have a unit circle, when the radius is not equal to 1? In other words, it could be a bigger one, bigger number, or a smaller number. So in this diagram here, I have a big circle. So the big circle has a radius of 3. And now if you notice the first quadrant area, you notice that there's 2 triangles. So you have a small triangle here embedded in the unit circle, and then you have a bigger triangle right over here embedded in the bigger triangle. And if you recall from the past grade 10, these 2 triangles, the blue small one and the red big one, they're considered similar triangles. And the reason why is that is because they both have a 90 degrees and they both share a common angle. In this case, it's around 42 degrees. So if you recall, this is AA, and because you have 2 angles that are the same, these two triangles, the blue and the red, are similar. And when triangles are similar, the size of the sides of the triangles have a certain proportion. Now in this case here, if you notice the x value and the y value for this, and compared to the x and the y value for here, there is a number, a common number that you can get. So if you take 2.2 divided by 0.72, put that in your calculator, you're going to get a 3. What that means is to get from here to here, you're going to multiply by 3. To get from here to here, you're also going to get multiplied by 3. So what that means is that this big red triangle here is actually 3 times bigger than the blue one over here. Let's turn our attention to this diagram here. So we go back to the unit circle. The radius is 1, and we established already that xy for a unit circle is corresponding to cos theta and sine theta. So xy is the same thing as cos theta sine theta. So if you want to find the x and the y for a non-unit circle where, let's just say the radius was 3, all right? What's going to happen to the sides of the triangle? Well, we just established that this blue triangle, the sides of the triangle, which correspond to xy, are going to be bigger compared to the red triangle here. But by how much? Well, by a factor of 3, because everything gets tripled. If the radius is 1, but now the radius is 3, we know that the blue triangle is going to get bigger by 3. So that means everything, all the sides of here are going to be multiplied or get bigger by a factor of 3. So in other words, we have cos theta and sine theta, but we're going to have to take this and do what with it to get the actual bigger size? Well, we're going to have to multiply by 3, the x and the y, or the base and the height. So we're going to multiply things by 3 and 3. But 3 is a specific number. Well, what happens if we just generalize it? Instead of calling it 3, let's call it r instead. Let's call this r instead. So instead of 3, we're going to put r. So instead of multiplying by 3, we're going to multiply not by 3, but by r. So we take everything here and multiply r. This becomes r and a r. So what this means is, what I just wrote down here is a general equation to find any point on the circle with any radius that you want. And of course, the circle, it has to be centered at 0, 0.